So today we're gonna do some AQA GCSE mathematics paper, and it's higher tier, it's non-calculator. So we have 1 hour 13 minutes. Just remember that you don't need a calculator for this, and in fact you're not allowed it. It's 1 hour 80, should be relatively simple, so let's get started. So the first question is circular fraction that is equivalent to 4.75. So 4.75, if it's a denominator of 4, you already know that 0.75 should be pretty trivial. It should be 3/4, and that's a 4 plus 3/4. So 4, if we were to denote with a denominator of 4, would equal to 16 over 4 plus the remaining 3/4, which should give us a net total of 19 over 4. So the answer should be that one. So that's question 1. Question 2, we have a factor, we need to find a column factor. So for column factor, the first element is the x value. So column factors are denoted x, y, which means that at the moment we're increasing by 3 on the horizontal and decreasing by 2 on the vertical, which means that we're looking at 3 plus 3. In fact, it's plus 3 on the x and minus 2 on the y. So you're looking at 3 minus 2, which is this one. Okay, now, which one of these are square numbers and a cube number? So you need to fulfill both aspects. So a square number is defined to be a number with a multiple of itself, and a cube number is a number that is multiplied by itself 3 times. So where we have zeros at the end here, we can estimate that the x, the base number, should be somewhere along 10, which means that now we can work it out by essentially trial and error. So 10 to the power 1 is 10, 10 to the power 2 is 100, 10 to the power 3 is 1000. So that's index of 1, index of 2, index of 3. And if we were to keep going, we can have more options, I suppose. And actually, this value over here is 10 to the power 6. Yeah. So for a number to be both a cube number and a square number, the index has to be a multiple of 2 and 3, which is at least a multiple of 6. So actually this is the only valid one, because sorry, I missed the 0 here. 10 is impossible. Well, 10 is not an option in this question, so ignore that. 100 has an index of 2, but it cannot have the index of 3 as well. Whereas 1000 does have index of 3, but does not have the index of 2, because they are prime numbers of each other. 2 and 3 are primes of each other, and hence you can't have it as both both a square and a cube, which means that you need at least a 10 to the power 6 to fulfill that. Right, so there you have the answer. This is a relatively hard question for 1 marker, but that's just life. Right, circle the reciprocal of 5 on 6. So 5 on 6 reciprocal is just upside down, right? So if you swap those two, you're 6 over 5. So there you go, that's the reciprocal. It's not actually that difficult, is it? Okay, trigonometry, work out the size of angle x. So these are right angle triangles. So you know that you have adjacent and hypotenuse, right? So you have A and H. If you remember the Sakatoa method, which I kind of forgot a long time ago, but I know that this is cosine of adjacent over hypotenuse is equal, the cosine of x is equal to adjacent over hypotenuse. That's the correct way to say it. And that would equal to 1/2, right? So because 9 divided by 18 equals 1/2, so cosine of x is 1/2. And the special angles should ring a bell in your head, and if it doesn't, which it doesn't to me, there is a way to remember it. I just need to somewhat remember it. That's over 2, so this is sines, and then cosine is the other way around. So I did a video on this a long time ago, but essentially there are special angle rules that you can remember. So this is 30, this is 45 degrees, this is 60 degrees, and at the moment we want to have a half on the cosine x, right? So the cosine x of a half, this value actually equal to a half, which means that what we're looking at here is actually 60 degrees. So this is 60, yeah. So these special angles, remember them, they're useful. And that's the sine and the cosine ones, and then the tangent one is just the sine divided by cosine, which is, if I remember correctly, it should be root 1, root 2, root 3 divided by root 1, root 2, root 3. So tangent of 30 is 1 on root 3. Tangent of 45 should be 1, and tangent of 60 degrees is root 3 over 1, which is root 3. So those are the special angles that you do have to remember, and you're doing a higher paper, so you definitely should know them. Okay, so now this is a bit of statistics. Graph A and graph B are scatter graphs, and which type of correlation is shown by each graph. So graph A looks like a decently good correlation going down, right? As x goes up, y goes down, which means it's negative correlation, and because it's a good straight line, it is strong, which means that we're looking at strong negative. So A is that. Whereas for graph B, you can see just a big cluster, essentially an ellipsoid or a circular distribution, which in statistics we call no correlation at all, because it doesn't tell you whether or not y is going to increase or decrease as you increase x. So it's actually just no correlation. So this is relatively trivial. Okay, so next we have some more, I assume these are more statistic questions. I've never read these questions before, so I have to work it out myself. So there are 80 people who play in bands, 12 of them are singers, but not guitar players. 30% are neither a singer nor a guitar player, and a quarter of them are singers, right? Which means that you've got the whole party of 80 people in this rectangular area. Singers are defined by the left circle and guitarists are defined by the right circle. So let's start with the information that was given. So there are a quarter of guitar players who are singers, which means that there are 1/4 in here and 3/4 in here, and they add up to 1 within the guitarists. And we know that 30% of them are neither singer nor guitar players. So outside here there are about 30%, and then within the two circles there are 70% in total, right? So we can start from there. 30% of 80 people is 3/10 of 80, which equals to 24 people. So there are 24 people outside, and there are, that would be 56 people within the circles. There are 12 singers that are not guitar players, which means that they have actually given us a number in this slot. So within the singer guitarist circle, which is this one on the right, we know that it is 56 minus 12 because 12 of them are already outside of that right hand circle. We know that there are 44 of them. And now we know that because we know 1/4 of them are sharing singer and guitarists, which means that 1/4 of 44 is 11. So actually within the middle there are 11, and within the right we have 33, which means that if I just clean up the diagram a little bit, removing all the things that we don't need, we should have this kind of distribution. So you have 24 on the outside, you've got 33 on the right, 12 on the left, and 11 in the middle. So that's the answer. These are the 4 marks. Right, so at question 8, we have a geometry question. The shorter side of parallelogram is 6.5 and the shorter side is 1/9 of the perimeter. So we can do some algebra. So first we want to label the long side as x because we don't know what x is. And we know that the perimeter P is equal to 6.5 times 9, because the shorter side is 1/9 of the perimeter. And that would give us 58.5 as the perimeter. And the perimeter of a parallelogram is defined as the long side plus short side times 2, which is 6.5 plus x, or times 2, is equal to your perimeter, which is equal to 58.5. And knowing that, we can now expand our bracket on the left to give 13 plus x is plus 2x is p, and we know that 2x is, well, if we take 13 from 58, we should get 45.5, and that would equal to 22.75 centimeters. So for these questions, make sure that you put in the answer into the answer slot rather than above, because they can be pedantic and not give you the mark, which is annoying, but what can you do? Right, so next we have a geometric progression. Geometric progressions are a, b to the r equations normally. So we have the second term is 4. So a b to the 2 equals 4. And we know that a b to the 4 equals 16. So we need to work out the first and third terms, and this is a relatively I suppose simple progression, because if you divide 16 by 4, you get 4, and you essentially have ab to the 4 divided by ab to the 2, which they essentially can just all cancel to give you b squared. So b squared equals 4, and we know that b is plus or minus 2, right? So remember, whenever you square root something, you don't know the sign, because negative times negative equals positive. But in the case of this geometric progression, you can't really tell whether or not it's plus or minus, which is the funny thing. So I'll assume everything is positive to simplify our brains a little. We know that b squared equals to 4, and we know b equals to 2. We assume b is plus 2. Not that it matters really for whatever they've given us. We know that a has to be equal to 1 in that case. Has to be positive 1 in this case, right? So now we know what a is, we know what b is. We can now construct our geometric progression. First term would be 1 times 2 to the power 1, which is 2. And the fourth term is 1 times 2, the third term is 1 times 2 to the power 3, which is 8. Now, this question have two valid answers in theory, because minus 2 for b is also valid, because you can't distinguish between minus 2 and plus 2 in this case. So in theory, you can say minus 2 and minus 8 as a valid answer, but I'm not sure how the exam board would want to mark this really. So I suppose I suppose you're just gonna have to deal with poorly structured questions. If I made this question, I would have structured, instead of giving a fourth term, I would give the third term or something like that. Right, 9b, the first two terms of arithmetic progression is shown as below, so p and 5p. So our first three term is 90. So this arithmetic progression, which means that it's constant, the addition of the number of p's are constant, so it goes via a plus b r as the equation. We know the first term is p, which is a plus b equals to p. We know that the second sequence is 5p, so you know that a plus 2b equals 5p. So now we can again do a bit of a subtraction of equations. We take 5p minus p, which is 4p, and then we have a plus 2b minus a minus b, or if you want to do it in brackets, it's a plus 2b minus a plus b. Just remember negative do go into the sign, and eventually you're gonna get b is 4p. So that's the first thing you want to know, and with that information we can work backwards to know that a equals to minus 3p, which means that the third term of the sequence is minus 3p plus 3 lots of 4p, which equals to 12p minus 3 is 9p. So in total, the sum of the first three terms is p plus 5p plus 9p, and that equals to 15p. 15p is equal to 90 because the question says so, and hence we now know that p equals to 90 divided by 15, that is 6. Okay, so that's algebra, a lot of essentially basic algebra, but because of how the question is structured, it could trip people up. Question 10. The cost of holiday is 2.4k. Rana pays a deposit following by monthly payments in the ratio of 3 to 5, and she makes 6 equal monthly payments. Right, so that is a lot of information in money terms, but these are all relatively doable, I suppose. So we know that the net total of the cost of the holiday must equal to the sum of deposit and monthly payments. Yeah. So the deposit and monthly total is in the ratio of 3 to 5, which means that one part of the, say, 1 unit of this number is just 1/8 of the total cost, right? Because there are 8 total parts that it's been split into. Right, so sorry, that's a poor notation. So 1 part cost is 1/8 of total cost. I'm trying to make everything as clear as I can, but so 1 part of the cost is 1/8 of the total cost, and we know the one total cost is 24 hundredths, which means that 1 part of the cost is 24 divided by 8 is 300. So £300 is the 1 part cost. We know the total amount of monthly payments is 5 parts. So 5 parts of 300 equals to 1,500. And this was equally divided by 6 parts. So divide by 6 would give us 2, and then that would be 3 is £250 as the answer. 250, right? So I'm gonna try to explain this again from scratch. Is you started with 2,400. You split the part into 8 equal parts, and you put 3 part of that into your deposit and 5 part of those as your monthly payments. And each of that part, each of the parts is worth 300. So the monthly payment part is 1,500, and the deposit part is 900. The monthly payments was split in 6 parts, which gives you a total of 250 per month as the payments. So that's how you get to the answer. Question 11 as a decimal, 11 over 40 is 0.275. That's very kind of them to give us that. And now we should work out the 33 over 400 as a decimal place. So what this is asking you to do is essentially algebraic manipulation, or trying to figure out how to essentially manipulate in the fractional numbers. So we know that if we want to get to a common denominator of 400, we need to turn 11 on 40 to 110 over 400, because you can multiply top and bottom by 10 and still get the same number. And so this whole thing is still equals to 0.275. All right. We want to get 33 out of 400. We have 110 out of 400. And we know that we can get from 110 to 33 by going through divide by 10, divide by 10 to get to 11, and then multiply by 3 to get to 33. So what we need to do here is essentially take this number, divide by 10, and then times 33. Oh, times 3. And then we'll get our answer. So to divide a decimal by 10, you essentially shift the decimal place up to the left by 1. So you're now on 0.0275 as your this one is 11 over 400, and now we multiply by 3 and we can get this is a simple multiplication. It'd be very embarrassing if I make this did this wrong, wouldn't it? So 0.0825 is the number after you multiply by 3, and so that's the answer to the question. So 0.0825 is equal to 3 over 400. So this is abstract. This is pretty hard, but if you can understand how to work with denominators and how to then subsequently manipulate your fractions, then it should be relatively trivial. Right. 2 Y shapes make an earring. The shapes are a circle, radius 21. and a quarter circle. The radius of the circle to the radius of the quarter circle, which is this length, is 7 to 2. So, which means that now we can do some more ratio stuff. So, 21 contains 7 parts, and each part is 3, right? Which means that if I want to have 2 parts, then I'm gonna have 6 as the number, because 3 times 2 is 6, right? So that means the radius, this is 6 mm. And oh, there you go, that's the question. Actually, I didn't even read the question. Yeah. So again, it's about ratio is about working out what each part is equivalent to. So 21 millimeter contains 7 parts, and hence you can work out what each part is equivalent to, which is 3, and then you can work out anything else so long as you know how many parts you're working with. In this question, it's 2 parts, which is 2 parts of 3. So 2 times 3 is 6. So that's how you get to the answer. B, work out total length of the wire in the earring, which means that we're trying to work out the circumference and the perimeter of the quarter. So first of all, let's do the easy one. The circle is, we know it is 2 pi r equals to perimeter of circle. And then for the quarter circle, we have 2 lots of radius as these 2 lines, and then we have 1/4, that's a half, 1/4 of the circumference, which is 2 pi r. And remember, the r's are different in these two things, so we need to be very careful. I'm gonna write r prime as a distinction. So r prime is the small one, and r is the large one. So you know that 2 pi r is 21 millimeters as given, is the perimeter of circle. We know that perimeter of segment is 2r prime, which is 2 times 6 plus 1/4 times 2 is a half, pi times r prime, which is 6. So now we can essentially simplify everything. And here we have 2 times 6 is 12 plus 3 pi. And on the top we have 42 pi. And we're giving the answer in terms of a pi plus b, which means that what we're doing, we're summing these two numbers together to get, this would be 45 pi plus 12. So that's the answer. Just the hardest bit is to remember the 2 r's are not the same, and don't mix them up together. S and t are positive integers, and you can expand the bracket to get x squared plus kx minus 40. So you want to find the smallest possible value of k. So in this case, we know that s and t has to multiply to 40. So s times t equals to 40. And the what we want to get is that S and T has to be as close to each other as possible, because if they are very different, then the S minus T would be relatively big, and that would cause K to be too big. So what we, well, essentially it's easy, I guess it's easier to just expand the bracket and show x squared plus sx minus tx minus st. That's the expanded version of the brackets. And here we can see that the k term is equals to s minus t, whereas the minus 40 is just the st, right? So that's why this is the case. So if that all makes sense, we need to figure out what we can make s and t as to be as close to each other as possible. So what we do systematically, we should do essentially list all the prime list all the factors of 40. So we have 1, we have 2, we have 4, we have 8, with 5, 8, we have 16, we have 10 as well, I think. No, 16 is not not a factor, sorry. We have 8, we have 10, we have 20, and we have 40. So these are the factors of 40, and the closest to that makes 40 is 5 and 8. So what we want a small value of k, so we want s minus t to be a negative number, probably, and we want either s or t to be 5 and 8, so we want 5 minus 8 probably. So s has to be 5 and t has to be 8, and the smallest value of k would be 5 minus 8, which is minus 3. That's the smallest value that can be. Unless the question did say that k is a positive integer, in which case we flip these two. So this is t, this is s, and the answer is still the same, because the answer is still going to be the same, because the modulus difference of 8 and 5 are always 3. But anyway, do read the questions. Don't be like me and make assumptions. So we have a... Oh, what have he done? Yeah, so this person has tried to solve this equation, and what they've done wrong is over here. So when x plus 2 is equal to 0, then x has to be minus 2, not plus 2, okay? It's not plus 2, it is minus 2 that you want. So this is why he's wrong. Like, he forgot to minus. That's a very silly mistake, and it happens normally very often, actually. So that's that, and then now we have oh, okay, so we're now given that c is a very big number, and we want to find out what 18C is. So we can ignore C for now, we just need to bear in mind that C is a thing. And we look at the 18. So we have 18 times C. So when you're working with index, multiplications are just, it exists. It doesn't matter that much until you get to the prime factors. So you want to degrade 18 into its prime factors. So we know that 18 is 2 times 9, which is 2 times 3 times 3, right? So that's the index. So we multiply that by C, and we can slot in the prime factors. So we know that we started with 2 to the 10 times 2, because we have a new 2 over here. We have 1 lot of 3 multiplied by 2 lots of 3. And then we have 5 to the 6, which we don't have another 5, so we just let it sit there and do nothing. And we know that 2 to the 10 times 2, if you know your index, is 2 to 11. 3 to the 1 times 3 to the 2 is 3 to the 3. And then 5 to the 6 is unchanged. So your answer is 2 to the 11 times 3 cubed times 5 to the 6. And here we go. We have a cube root for some reason. And yeah, the first thing you can do here is to see the 2 to the 7 and the 2, and they can cancel. So you have essentially 2 to the power 7 minus 1, which is 2 to the 6th. And now you have the whole thing as a cube root of 2 to the 6th times 11 cubed. And because you're multiplying in the middle, in between the cube roots, you can just split the cube root into 2. So in cube root 2 to the 6th times cube root 11 cubed. So 11 cube rooted is 11. 2 to the 6th cube rooted is 2 to the 2. Cube root is divided by 3 in the index, which means that you have 4 times 11 equals to 44. That's your answer. And let's take a break here. We'll finish the second half of this paper. We stopped at 15 and we have a bunch more to go, but we'll get to the end. Hope you've enjoyed the video, and if you've learned something, do let me know in the comments below. If I've made any confusions, do tell me as well, and I hope to see you again next time.